Okay, so let's jump right in. When you hear the word ceramics, what's the first thing you think of? Probably, I don't know, a coffee mug, maybe some tiles in your kitchen?
Sure, and that's fair, but the real story of clay, it's not just about art class.
Not at all. It's actually one of the oldest and most important technologies humans ever came up with.
Absolutely. We're talking about a material that took us from digging basic dirt out of the ground all the way to, believe it or not, protecting space shuttles.
It's kind of mind-blowing. And today, we're going to unpack that whole journey, the key breakthroughs, the science, and how this ancient material is still, shaping our future.
So let's go way, way back to the very beginning.
Prehistory. Early humans figure out something that just changes everything. They see that wet clay can be molded.
Right, but the real magic happens when you add heat. Maybe they left a pot too close to the fire by accident?
And they realize it doesn't just dry out, it gets hard, like permanently hard.
That idea of permanence was a revolution. I mean, before that, what did you have? Wood that rots, baskets that leak.
So pottery's first job was just super practical. Storage.
Purely practical. You need to store water, you need to store grain, and crucially, you needed to protect that grain from, pests and mice.
And how did they actually make them? We're not talking about fancy equipment here.
No, just their hands. The earliest methods were incredibly simple, like pinching a lump of clay into a little bowl.
Or coiling, right, where you roll out long ropes of clay.
Exactly. You roll out these long snakes of clay and then stack them one on top of the other, slowly building up the walls of the pot.
Which sounds really difficult. And it means every single piece would be unique.
Completely unique. A one-off. It showed the skill of the person who made it, right there in the final object.
But that one-off artistic process isn't great for, say, a growing town that needs a lot of bowls.
Exactly. And that brings us to the first massive technological leap, the invention of the pottery wheel.
This is where things start moving a lot faster, literally.
The wheel is, at its core, just a heavy rotating disc, but its impact was just enormous. It brings physics into the game.
Kinetic energy.
Right. So instead of slowly coiling, a potter throws a lump of clay onto the center of this spinning wheel,
And uses the force of the wheel to pull the clay upward.
pulling it up into a perfectly symmetrical, round shape in just a few minutes, not hours.
But those early wheels weren't electric, of course. You had to push them by hand or pump them with your foot.
Oh, it was a workout. It took a ton of strength and coordination to keep that wheel spinning at a steady speed and shape the clay at the same time.
The payoff, though, must have been huge.
Huge. You get speed and you get precision. The walls of the pots could be much thinner, more even. And that consistency,
That's what allows for mass production.
for the very first time. Now, you could make a set of 20 identical bowls. Pottery goes from being a unique craft item to a standardized product.
Which totally changes the economy. You can have workshops now with people specializing in different jobs.
Absolutely. But, shaping the clay is only half the battle. The really critical scientific part comes next.
The firing.
The firing. This is what turns that wet dirt into a permanent, rock-hard ceramic object.
So what's actually happening in the fire? What's the science?
It's a chemical transformation. The intense heat makes the minerals in the clay fuse together into like a glassy structure. It's called vitrification.
And once that happens, it's irreversible.
Completely. You can soak it in water for 1,000 years. It will never go back to being soft mud. That's why we still find it.
And early on, they were just using open fire pits, which I imagine was pretty hit or miss. The heat would be uneven.
Very uneven. Things would crack, sometimes even explode. That's why the invention of the kiln was another game changer.
A kiln is basically just a special kind of oven, right?
A very special oven. It lets you control the environment and get to much, much higher temperatures. We're talking well over 1,000 degrees. And that steady, even heat is the key to making strong, reliable pottery without cracks.
Okay, so we've been saying clay, but not all clay is the same, is it?
Not at all. What you can make depends entirely on the kind of dirt you have access to.
So let's break down the main types. What's the most common?
That would be earthenware. It's found almost everywhere, and it's fired at the lowest temperatures. Because of that, it stays a little bit porous.
Porous, meaning it can absorb a little bit of water.
Right, which actually can be useful. If you store water in an earthenware pot, a tiny bit seeps out and evaporates, and that cools the whole container down.
An ancient refrigerator.
Basically, yeah. Then if you fire the clay hotter, you get stoneware.
Which is, I'm guessing, strong like stone.
Exactly. It's much denser, it's not porous, perfect for holding soup or milk without it leaking.
And then there's the top tier, the ultimate ceramic.
Porcelain. And for this, you need a very specific, super refined white clay called kaolin.
Kaolin.
It's very pure, and it needs incredibly hot kilns to fire properly. But when you get it right, something amazing happens. It becomes translucent.
So light can actually shine through it.
You can literally see a shadow of your hand through a thin porcelain cup. To people in the ancient world, that seemed like magic.
So your local geography really determined your technological ceiling. If you didn't have kaolin, you just couldn't make porcelain.
You couldn't. Now, once you have your pot fired, people wanted to make it look good, right? Not just useful.
Decoration.
And waterproofing. They'd carve patterns into the damp clay or press things like shells or fabric into the surface to create texture.
What about adding color?
They'd paint with mineral pigments. The cool thing is, the colors often change completely when they get heated in the kiln. It's chemistry as art.
But the really crucial addition for function was the glaze.
The glaze is the superstar. It's basically a liquid mixture of minerals that, when you fire it...
It melts into a thin layer of glass.
Exactly. And that glass coating does two vital things. First, it gives you all the cool colors and shiny finishes.
And second, and this is the big one, it makes the pot waterproof.
It completely seals it. So that porous earthenware we talked about, now it can hold wine or oil for years without leaking a drop. That single innovation, it supported the growth of cities.
It's amazing to think that something as simple as clay was like the physical hardware for ancient civilizations.
Totally. Look at Mesopotamia. They didn't have paper. They wrote on clay tablets.
The world's first hard drives.
Pretty much. And they're permanent. We can still read them today. They also used giant ceramic jars to store grain and oil. This allowed them to feed large populations and plan for the future.
And then you look at a place like ancient Greece, where pottery becomes this incredible art form.
Right. Their vases weren't just for storage. They were covered in amazing paintings of myths and heroes and athletes. They were high-value trade goods.
But when you trade those pots, you're not just trading olive oil.
Yeah.
You're trading ideas. You're spreading your culture.
No question. And speaking of high-value trade, that brings us back to porcelain.
The white gold.
That's what European traders called it when they first saw it from China. It was so strong, so white, so thin. They had never seen anything like it.
And the Chinese had a complete monopoly on the technology for centuries.
They knew where to find the kaolin clay, and just as important, they knew how to build kilns that could get hot enough. The rest of the world spent hundreds of years trying to figure out their secrets.
That technological race brings us forward to the Industrial Revolution. This is when pottery goes from a craft to a full-blown industry.
Yep, factories with steam engines, using molds instead of a potter's hands.
So they could just stamp out thousands of identical plates and cups.
Super fast and super cheap. Suddenly, regular families could afford a nice set of dishes. It totally changed daily life.
And that durability, the fact that it lasts forever, is a huge gift to us now, to archaeologists.
Oh, it's probably the most common thing they find. Pottery shards are everywhere because they don't rust or rot.
And from one tiny piece, they can figure out so much.
An expert can look at a shard and tell you when it was made, where it was made, just based on the style and the material.
It becomes like a clock for dating everything else they find at a dig site.
It's even cooler than that, though. They can do something called residue analysis.
Okay, what's that?
Because some pottery is porous, tiny bits of food and drink get trapped inside the clay itself.
No way.
Yes, and scientists can analyze those microscopic residues and tell you exactly what people were eating or drinking thousands of years ago.
That is incredible. So the story doesn't end in the past. Ceramics are a huge deal in modern technology, too.
A massive deal. And it's because of two main properties. They can handle insane amounts of heat, and they don't conduct electricity.
So the space shuttle, when it comes back to Earth, the friction creates unbelievable heat.
And the tiles on the outside of the shuttle that protect it, those are made of a special, highly engineered ceramic.
They're designed to basically burn away slowly, taking the heat with them.
Exactly. But ceramics are also inside your phone.
In my phone. Where?
They use something called piezoelectric ceramics. These are materials that vibrate when you apply electricity to them. That's how the tiny speaker works, how you get that little buzz for notifications.
Wow. And they're also used to insulate all the computer chips, right?
Yep. They can handle the heat from the chip while keeping all the electrical signals separate. They're also in car engines, even in medical implants like hip replacements.
Because they're super strong and the human body doesn't reject them.
Exactly. So when you step back and look at the whole story, it's just this amazing journey of human innovation.
We started with what? Sun-dried mud, to hold some seeds.
And now we're using that same fundamental science to build parts for spacecraft and computers.
The journey from a simple hand-built pot to a component on a microchip is it's an incredible story. It shows how one idea can fuel thousands of years of progress.
So what functional yet beautiful object will you build next?
Good luck with your studies.